Good morning, everybody, or afternoon or evening, depending upon when you're watching this video, I suppose. It's morning for me. Uh, I'm gonna record the video today with my AirPod microphone and see if maybe that works a little bit better. I'm told that if we use microphones instead of the actual microphone in the camera, it sounds a little bit better. So we'll give it a shot and see what happens. Plus, I got these new AirPods for Christmas. So anyway. Please, first of all, do not forget that your midterm exam is this week. So make sure that you do that. We're also covering Chapter 7 on experimental designs this week as well. So please make sure that you review that content as well as listen to all that I am going to have to say about it as well. So anyway, you guys are probably familiar to some extent with an experimental design, right? And it usually assigns or involves assigning people to two random groups, one being a control group, the other being the experimental group. One of the classic examples is maybe back when you're testing pharmaceutical drugs, and maybe you give some people the drug to cure cancer, and you give some people a placebo drug, which is just a sugar pill, to see if this drug is actually effective at resolving the cancer or whatever other types of issues that people might be having. They're very common in the health sciences. Psychology uses them a lot. They're probably a little bit less prevalent in criminal justice research for the main reason that it's kind of unethical for us to kind of assign some people to prison and other people not to prison, or some people get drug treatment and other people don't. So that's used a little bit less, with the exception of when you saw the Stanford prison experiment and things like that that happened a long time ago before we were really had this crackdown on ethics, so to speak. But anyway, so just to talk about the classical experiment a little bit, you'll have your variables. Of course, they need to be time ordered, so your effect can't happen before your cause. The cause needs to happen first. And so there's some other independent or dependent variables which are important. Remember, your independent variable is kind of your cause, the dependent is your effect, and the pre-testing and post-testing. So you want to get an idea of what people's status is before you conduct the experiment and then afterwards as well. So in the cancer experiment, you want to see, well, do they have cancer beforehand, or what to what extent do they have cancer, and then after the experiment, did the cancer go away, or has it at least been reduced? Has the mass been reduced? Things like that. That gets into your pre and post testing. And then your experimental and control groups. Like I said, you have one group where you deliver the treatment to, and then another group that's a control group that doesn't get the treatment. You usually don't want the groups to know who has the treatment and who doesn't, and oftentimes you don't even want the researcher to know because that can bias your results. Um, so the independent variable would be your treatment, so to speak, or your cause, your experimental process, whatever it is that you're doing to people to see if it's or it's effective. Is drug treatment effective at reducing future drug use, or is this pill cure cancer or HIV or anything else like that? And then the dependent variable, obviously, is the outcome, as I've said before. Um, the post-testing and pre-testing, like I said, these are just measured beforehand and then after the fact to see if things have actually been effective at reducing or fixing things within the design. I already kind of talked about the experimental group versus the control group, so I won't bore you all with listening to that too much. Again, in order to not be redundant, the Hawthorne effect is pretty interesting, and this is also known as reactivity. So, will people behave differently if they know that they're being watched? And so this started with Hawthorne and his experiment. He wanted to test if the workers in an environment, if they got better lighting, if they would work better, if that would improve work conditions. They actually found out that it did, but it was because the workers knew that they were being watched that they started working better and being more productive, if you could imagine. So that kind of gets at the idea that you don't want the people to know that they're a part of an experiment, otherwise they might change their behavior just as because they're being watched. The placebo I've kind of already talked about. This is just like a sugar pill in the cancer experiment, so that way people won't know whether or not they're getting the placebo or not. Now, this is your ideal stage or ideal situation, so to speak. But if you're getting a sugar pill versus a cancer treatment drug, you're probably going to know because usually these drugs have uh, very easily to identify side effects, nausea and vomiting and things like that, whereas the sugar pill is not going to have those things. So people might be able to figure it out, but you try your best not to. Like I said, you don't want the individuals to know. That would be a single blind experiment. The individuals don't know who's in an experimental versus control group. A double blind experiment would be when the individuals that are in the experiment don't know, as well as the researchers don't know who's been assigned to the experimental versus the control group. And that can help for people not to try to pick up results where it might not be there. And it makes a truly objective, so to speak, experiment. So selecting subjects, you must decide on the target population, particular members from that group for your experiment, and you want to make the control group and the experimental group as similar as possible. You don't want to have an experimental group with all men and a control group with all women, or age differences. You want to keep them as similar as possible. And usually people will use what is known as randomization, where you randomly assign people to control or the experimental group. And this is the central feature of the classical experiment. This is what really makes the experiment so good at being able to get at that kind of causality, the three criteria that we already talked about with the temporal order, the concomitant variation, as well as that being able to rule out the other factors. Because since the differences between the control and the random, or the control and the experimental group are random, there can be no systematic variations between them. So any differences between the control and the experimental group should be attributed to whatever that treatment was, whether it was that drug use treatment or the cancer pill or whatever your treatment was in your experiment. So that's the big cool thing about experiments, so to speak. So, as I already said, the experiments and causal inferences, they are potentially control for many of these things that are really big threats to our causal inferences, like I just said. And so the threats can be kind of due to conclusions drawn from experimental results, may not reflect what went on in the experiment. So external events may occur during the course of the experiment that maybe you don't know about. So there are some threats. Maturation, people, as you probably know, there's an age crime curve. So if you did an experiment over time, people might desist from crime over time if you're trying to measure that. And so that would be just an effect that you would see with that. There's also sometimes testing effects. So if I asked you to take an exam, maybe I had you take your midterm exam, and then I didn't give you a review at first, and then I gave you a review after your midterm, and then asked you to take the midterm again, and then you did better. Well, I couldn't necessarily say that it was because I gave you the review. It could be because you've taken the test before, right? So testing effects means because you've already taken the test, you might do better at it just because you've already taken it before. So other threats, instrumentation. You could have changes in the measurement process, although you really want to try to not have that. Statistical regression, we won't get into too much in this course, but these extreme scores will tend to regress towards the mean. If you have a large enough sample, you could have selection bias, which of course hopefully you do not have, since you have the random assignment. You also could have issues with experimental mortality. Subjects might drop out, they might die. In criminal justice research, one of the big problems is if you're trying to follow people over time, they'll get arrested and they'll get locked up and they'll get imprisoned, and then they'll no longer be part of your experiment. Or it often happens that people that are involved in crime do die at a higher rate. They get shot and things like that, or there's drug use and stuff can cause them to die. So the causal order, I've already kind of talked about that. You want to make sure that your stimulus happens before the dependent variable. Otherwise, you can't prove causality, diffusion and imitation of treatments. So, elements might pass on, and I think we see this with the Kansas City patrol experiment because we had the control group areas, but then even in the reactive areas, there were still police cars going through there to respond to calls, and so that might be interpreted by passerbys as patrols. They wouldn't really know that this is reactive, so that you can get kind of this passing elements between the two that can be a problem. It's less of a problem with others. Demoralization, compensatory rivalry. Some people, will be kind of upset if they're in the control group, especially if it's a cancer treatment issue, right? Demoralization. If you're really hoping to get into this study for, cancer, and then you get into the control group, you might kind of give up and not work too hard towards it, which could actually affect the results as well. Um, so there's some generalizability issues and threats to validity as well. With the big one with experiments being that while they have a whole lot of internal validity, they really don't have a whole lot of external validity, and they're very difficult to generalize to the entire public because they're not based on a random sample of the entire population. They're usually a very small subset of those. So they're very good for testing treatment drugs and things like that, but you couldn't necessarily use it to say, well, this will work for everybody in the entire country. You can just say, well, within this clinical trial, it has been effective. So there's some threats to construct validity, sorry, which your textbook will review as well. And this is really an important part as well. You want to make sure that you develop your constructs well. Um, Anything else that I want to say about this? It really just gets at kind of a lot of these issues with applied studies and external validity versus your explanatory studies such as this. And it kind of puts you at this dilemma. Do you want the increased validity of the experiment without the generalizability, or do you want the generalizability without the internal validity? It really just, it's your decision as the researcher to decide what you want to do, and it really depends on what you're trying to study, what you're trying to prove, which is why experiments aren't used as much in criminal justice. Statistical conclusions, sometimes this can be an issue. One of the big things with experiments is the lack of statistical power, because you usually don't have that many people, so the number of subjects down here is usually pretty low, and so that can be an issue with that. So there's four basic building blocks present in experimental designs: the number of experimental and control groups, the number and variation of the experimental stimuli, the number of pretest and post-test measurements, and then the procedures used to select subjects and assign them to groups. And so these are the various ways that it's kind of varied. There's also what's known as quasi-experimental designs, and these are attempts at kind of creating an experiment without actually doing it. And so you have time series designs, non-equivalent control groups, and this is usually occurs when randomization isn't possible for legal or ethical reasons, which happens quite a bit in criminal justice. And so then you might take some existing data and then try to randomize it or something like that. We can include equivalency, hence the name, sometimes, and sometimes we can't. Usually we cannot randomize things because we don't have control over who gets sent to prison and who gets parole and who gets probation and who gets who the police shoot or who they don't and things like that. And that would be a big ethical problem for us too, right? And so there are these other designs, the quasi-experimentals try to do that. There's some cohort designs that you can talk about, time series designs. These are other examples. I'm trying to wrap up here because I'm about to hit 15 minutes. So just kind of read through your textbook and check with that. And I will see you all next week. And please don't forget to take your midterm and email me if you have any questions. Thanks.